Hey, so we've been studying this couple sample cases of states that have cases reported of COVID-19, one set of 9 states and one set of 7 states, just to try to unpack or to make known some of these ideas about statistics that we like to do. And the first thing was just look at the average number of cases. So in this first case, the average number of cases was 534 approximately. Over here it's only 134. But looking at averages only tells part of the story. The other part of the story that we would like to tell is how spread out are the data. If the data are really spread out or less spread out can tell us more about the situation, and as you study different contexts, you'll see what I mean. But in this case, let's get a way to measure how spread out the data are. Here's how we do it. So here's all the numbers from the PowerPoint that you saw. The first thing we figure out is how far from the mean. So when we talk about spread outness, we talk about it in the sense of just how far from the mean is each of these number of cases. So for instance, this state had 152 cases. The mean, or the average, was 534.3. So how far from the mean, or the difference from the mean? Just subtract and see. When you subtract 152 and 534.3, you get 382.3. But now, when we do this subtraction, we also want to know, is it above the mean or below the mean? 152 is clearly below the mean. So what we do is we indicate that with a negative. A negative is below, a positive would be above. We do that for each of the 9 cases, or the 9 states. 164 is below the mean by 370.3. Now 1709 is clearly above the mean by 1174.7. Now by the way, you should be doing this along with me. What I'm doing is taking the number of cases and subtracting the mean. Number of cases, subtract the mean. Number of cases, subtract the mean. That's how I'm getting these numbers. Check it out on your own calculator and see. 591 is just a little bit above the mean, 56.7. 327 is below the mean, so negative 207.3. 56, clearly way below the mean, 478.3. 116, below the mean by 418.3. 937 is above the mean, so positive 402.7, and 757 is above the mean, positive 222.7. So great, we've now subtracted to find out how far from the mean is each of these number of cases from each of the 9 states. What do we do with that? Well, I'm going to challenge you, after I say this, pause your video and do what I'm about to tell you to do. Take all of those numbers and add them together and see what you get. Go ahead, pause. You didn't pause it. You're not gonna just pause the video and add all these numbers together, okay? All right. Now, if you did that, something interesting should happen. So all of these numbers together, if you add them up and think about like an average, a mean, it wouldn't really produce anything useful. And so, what statisticians have done is said this: let's not concern ourselves with whether or not the number is above or below the mean. Let's just concern ourselves with how far from the mean. That is, let's find the absolute difference, the absolute value, just total distance. Don't concern yourselves with above or below. Just say, this number is 382.3 away from the mean. This number is 370.3. This number is 1174.7, etc., etc., etc. Just look at the raw difference from the mean, regardless of whether it's above or below. We call that the absolute difference from the mean. Now, all of these numbers are positive. So, to kind of get a sense of, for this particular data set, for these 9 states, how much do their cases deviate from the mean, we could take those absolute differences and take their mean. So add all these together, divide by 9, equally distribute that sum, you will get an answer of 412.6. Now this number is known as the mean absolute deviation, the MAD. What the MAD tells us is, on average, how far do our number of cases deviate from the mean? On average, they deviate from the mean 412.6 cases of COVID-19. Now when we do that over here with our second sample size, our set of 7 states, we can now compare. I'm going to have you do this, so I won't do it now, but imagine we did the same routine over here and we get a certain mean absolute deviation. We compare it to this mean absolute deviation and we can now say something about this data set compared to this data set. But before you go and do that, I would like you to consider another thing that statisticians have done. You saw the issue of this sum of numbers, some positive, some negative, they add up, you get 0. Whew, doesn't help us a bit. And so we did the absolute value, the absolute difference. Well, another strategy statisticians have used to fix this problem is, instead of absolute value, square this difference. How far from the mean squared? Because when you square a negative times a negative is a positive. When you square a positive, you also get a positive. So this time, square all of these numbers. Take 382.3 times itself, you get 14617.8. Square 370.3, you get 137,146.8. Square 1174, oh my gosh, you get 1379842. Now, don't just watch me write all these numbers. Get a calculator out and actually square these numbers so you can see where I'm getting them from. Square 56.7, you get 3,211.1. Square, where am I? 1, 2, 3, 4. Square 207.3, you get 42987.1. Square 478, 228802.8. Keep going. Don't stop. And finally, now by squaring all the numbers, we get the positive results. So now we can do something with all of these positive numbers. And again, just like with the absolute differences, we'll take those squares and we'll average them. Take all those numbers, all 9 of them, add them together. Get a grand total. Divide by 9, equally distribute them among the 9 states. What you'll get is 25832.1.3. That number has a name. It's called the variance. So look at what we've done here. How far from the mean squared? How far from the mean squared? How far from the mean squared? Average it up. So this set of numbers, on average, the squares of their differences from the mean average 258,321. Now remember, this came from squaring all of those differences, squaring the number of cases and how it differs from the mean. So it would be like a squared number of cases. So if you think back to your algebra days, at one point you said, say you had an x squared is equal to 9. What number squared gave you 9? You know that that number would be 3. And the way you could find that out is you could take the square root of 9 to get 3. Well, likewise over here, since all of these are based on squaring the differences from the mean, we can unsquare, we can square root that variance. We can square root 258,321 and get 508 about 0.3. And this number is what's known as the standard deviation. So what we would say is this data set has a standard deviation, a spread outness from the mean on average of 508.3. Now, alone, just on this one set of data, this number and really even this number, And even the average don't really tell us that much. What's interesting is when we have data sets and we compare them to other data sets, that's when we can make more meaning and to say more about the story about these data sets. So, average, how spread out. MAD, variance, standard deviation are just different ways that we can measure spread outness. Now, what I'd like you to do is grab the 7 states in our second case, had a mean of 134.7, and fill out this chart. Pause the video, fill out the chart. Actually, I'm gonna stop the video and I'll make another video so you can check your work on this. So, take a minute, grab a piece of paper, get to work, come back when you're ready, you can check your work, we'll talk this through. All right, go get them.